Okay, to solve this system of equations, I need to look at the x's and see if they will cancel. Well, negative 5x plus x does not cancel to make 0, plus 3y minus y does not cancel to make 0. So I have two options. I'm going to choose to take the bottom equation and multiply it by 5. When I do that, I get 5x minus 5y equals 20. Stack the bottom equation underneath it, which is minus 5x plus 3y equals 6. Add these together. The x's cancel. I get negative 2y equals 26. Divide by negative 2. Divide by negative 2. We get y equals negative 13. Plug that back in. I'll plug it into the bottom equation. So that's going to be x minus negative 13 equals 4. Well, this is a plus 13, so I'm going to subtract 13 to the other side. And I get x equals negative 9. So my answer is negative 9, comma, negative 13. Okay, let's talk a little bit about the midpoint theorem. We did talk about what a midpoint is. So if point M is equidistant from A and B, then what do you notice here? And we wrote this down in our notes the other day, or on our homework the other day. We know that line segment AM is said to be congruent to line segment MB. That's our midpoint theorem. So A is the midpoint of CT. If CT is 16, find CA and AT. So you know you have this line segment CT. A is the midpoint. Well, if the whole thing is 16, how long is CA? Well, that's just half of that, so that's 8. And how long is AT? Well, AT has to be the same size as CA, so that's also going to be 8. Okay, what if A is the midpoint of CT? And we know CA is 3. Well, if C to A is 3, how far is it from A to T? A to T also has to equal 3, because that's what midpoint means. So what does that mean about CT? CT is going to be 6. So if you look here, a line or ray or a segment that intersects a segment at the segment's midpoint is called a segment bisector. So if you look at our picture, we have line L. Okay, it's going through midpoint B, but if you look at this picture, you got the hash marks on it. So we know line segment AB is still congruent to line segment BC. Let's draw a picture. Ray BC bisects line segment JK at point B. So we have a bisector, which automatically means we have a midpoint. Our midpoint's going to be B. So I'm going to draw line segment JK. Point B has to be our midpoint. Put our hash marks on here. And we need ray BC. Ray BC is going to start at B, and it can go any which way you want towards C. That's what that would look like. Now I could draw it above it. I could draw it to the left. I could draw it to the right. It doesn't matter. Okay, let's try something a little bit more complicated. If A is the midpoint of CT, CT equals 16. What is x if CA equals 2x plus 4? So draw a picture. I have line segment CT. A is the midpoint. Put my hash marks on there. I know CT is the whole thing. The whole thing is 16. I know CA is 2x plus 4. Well, the deal is, since A is the midpoint, if CA is 2x plus 4, then what do we know about AT? it has to be the same size. So it has to be 2x plus 4. So basically, if we take CA and double it, that's going to equal 16. So add together the pieces. What am I going to get? 2x, that's going to be 4x plus 8 equals 16. Subtract 8 from both sides. We get 4x equals 8. Divide by 4, and we get x equals 2. How do I check my answer? I plug it back in. 2 times 2 is 4, plus 4 is 8. 2 times 2 is 4. 8 plus 8 is 16. So that's one way to do a midpoint. Over here, part B, guided practice number 4. B is the midpoint of AC. So what my drawing is missing is tick marks on it. Well, what do you know about line segment AB and line segment BC? They're equal to each other. So what that means is 2x minus 8 has to equal x plus 17. Okay, subtract x from both sides. And then we're going to add 8 to both sides. And we get over here is x equals 25. We're going to check to make sure we're right. 2 times 25 is 50. 50 minus 8 is 42. And x plus 17, that's 25 plus 17. That's also going to be 42. So we checked our answer. We did a good job. Let's try a challenge problem. Line segment PQ is bisected by ray RS at point R. So bisected means we have a midpoint. Our midpoint's going to be R. So we're going to draw a line segment PQ. It's being bisected at point R. So here's R. R is my midpoint. So we got our hash marks. Okay, ray RS has to be drawn in here. So ray RS starts at R. It can go any way as long as it goes towards S. So on this picture, we know P to Q is 3 times x plus 7. We know R to Q is x plus 23. Well, what do we know about RQ and PR since we had a midpoint? We know those have to be the same. So if RQ is x plus 23, PR is also going to be x plus 23. To set up our equation, we're going to double x plus 23. So we're going to get 2x plus 46. And we're going to set that equal to PQ. Well, I'm going to go ahead and distribute this. So that's going to be 3x plus 21. Subtract 2x from both sides. Gonna subtract 21 over here. We're going to get 46 minus 21 is 25 equals, over here we have x. Double check our answer. We're going to plug 25 in. What's 25 plus 23? It's going to be 48. So PR to Q is also going to equal 48. And then what's 25 plus 7 times 3? 32 times 3 is 96. And what's 48 plus 48? 96. So we checked our answer. Okay, one other challenge problem. Draw a picture. A is between C and T. So we got C, T. A is somewhere in between. Does it mention anything about a midpoint? No, so we're just going to put A somewhere. I'll put it right here. It says that we know C to T, that's the whole thing, is x squared. Ooh, so this looks like a quadratic to me. It says C to A is 3x minus 4. And between A and T, that's going to be 4x minus 8. So we're going to set up our equation. We're going to add together the x's. So that's 3x plus 4x. It's going to be 7x. And We got minus 4 minus 8, so that's going to be minus 12. And we're going to set that equal to x squared. Well, anytime I see an x squared, I need to move everything to the same side as the x squared. So we're going to move 7x over. We're going to add 12 over. When we do that, we get 0 equals x squared minus 7x plus 12. Now we have to factor this. So I'm going to scroll down and do some of my work down here because I don't have any room. So first thing I'm going to do to factor this is I have to look at the a and the c. This is 1. The c is 12. Remember, we take 1 times 12. Well, 1 times 12 equals 12. We're looking for two numbers that multiply together to give you 12. But those same numbers have to add together to give you guessed it, negative 7. So I'm looking at all the multiples of 12. I think of 4 times 3. So is it true? They're both going to have to be negative. So negative 4 times negative 3 gets you 12. Negative 4 plus negative 3 gets you negative 7. So here we still have a coefficient of 1. So we take our negative 4 divided by 1. Take our negative 3 divided by 1. We're going to put the x's on the bottom because those fractions don't reduce. And we've got x minus 4 times x minus 3. Set that equal to 0. Add 4 to both sides, so we're going to get x equals 4. Add 3 to both sides, and we're going to get x equals 3. So I have two answers here, actually. X might be 3, and x might be 4. So x might be 3 and x might be 4, so you have two different situations you have to check. You have to check what happens when x is 3. Well, 3 squared is 9. 3 times 3 is 9 minus 4 is 5. 4 times 3 is 12 minus 8 is 4. And what's 5 plus 4? 9. So that works. So x equals 3 works. It checks out. The other x you had was 4. Check it out. 4 squared is 16. 3 times 4 is 12 minus 4 is 8. And 4 times 4 is 16 minus 8 is 8. And 8 plus 8 is 16, so that works too. So x could be 3 or it could be 4. They both work.